Hi everyone, we got cut off. Let's continue. You take each of your raw scores and we'll subtract the mean. So we have -1. Here we had -5 minus 1.4. So we got 6.4, minus 6.4. Then -1 minus 1.4 gives you a negative 2.4. Okay, the next one is a value of 2. So 2 minus 1.4 is positive 0.6. And then we have 3 minus 1.4. This gives you a value of 1.6. And finally 8 minus 1.4. This gives you a value of 6.6. Okay, so now you take each of those scores and square them, because if you were to add up minus 6.4 minus 2.4 and, you know, take these negative numbers and add it to these positive numbers, this sum here is going to equal 0. And that information is essentially useless. So what we're doing is essentially taking the absolute value now of these data values and we're going to square them. So if you take negative 6.4 and you square it, you'll get 40.96. If you take negative 2.4 and square that, you'll get 5.76. 0.6 squared gives you 0.36. 1.6 squared gives you 2.56. And finally, 6.6 squared should give you 43.56. Now, if you add up all of these values, this will give you 93.2. So, we have the sum of each x minus the mean squared. If we add them all up now, we want the sum of those, 93.2. Okay, so we need that to compute the standard deviation. So once again, the standard deviation tells you about your spread. It tells you the number of standard units you are from the mean for each particular data value you have. So let's compute the standard deviation. That's going to be the sum of each score minus the mean squared divided by n minus 1 degrees of freedom. And then you have to take the square root, because this formula is essentially the variance. But because we squared everything here in this column, we have to take the square root to get that standard deviation back, essentially. So the standard deviation in this case is going to be the square root of this 93.2 divided by n minus 1. We have 5 data values, so 5 minus 1 is 4. And when you compute that, that's going to be equal to 4.8270. So say hypothetically our data represents feet. Okay, so if our data represents feet or inches or anything else, if the data's feet, then our standard deviation is going to represent feet. So let's look at this data now on a number line once again. So I'm going to erase this. Now let's draw the bell-shaped curve. Okay, so here is our mean at 1.4. Okay. So who can tell me now what the first standard deviation is going to be? So one standard deviation, anybody know? Well, if you're not sure, you take that mean and you're going to add the standard deviation. Let's round that though. Let's say this is really, say it's approximately equal to 4.8. It's going to make computation a lot easier. So here's what you do. You take the 1.4, if that's your mean, you're going to add 4.8. So 1.4 plus 4.8 gives you 6.2. So one standard deviation is 6.2. Then you take 1.4, well actually 6.2 plus another 4.8. So you're adding the standard deviation a second time. get 11.0. So this is 2 standard deviations. 3 standard deviations, you take the last value, which is 11.0, and you add 4.8. Get 15.8. Okay, so this will be 3 standard deviations. Now, going the opposite way, you take 1.4 and you subtract 4.8. You go in the opposite direction. But to save time, we would say that, you know, like look at our scores. We have, if you have a score of 3, just for example, you know, if this is mean of 1.4 and the next data value would be standard would be 6.2, your 3 is going to fall in here. And then same with 2. 2 is also going to fall here within 1 standard deviation. Whereas 8, where is that going to fall? The score of 8 is going to fall here between 1 and 2 standard deviations. And then you would do the same thing on the opposite side. You would just take that mean and then subtract off that standard deviation to find out what that value would be. And then you would know exactly where these data values lie. So the standard deviation, once again, just represents how your raw scores deviate from the mean. And they're going to be in the exact same units as the data in your original problem, or your raw data. Well, I hope this has been helpful and that you've enjoyed this. Thanks.